Hello everyone, welcome to Shibe's chemistry classes. Today we have to start the physical and chemical properties of acids. In our previous lecture we have seen acids, some of the acids and its reaction, and classified acids on the basis of different points, like on the basis of sources, on the basis of strength, on the basis of basicity. So these points we have covered in the previous lecture. Now in today's lecture we have to see the physical and chemical properties of acid. The first is the physical properties of acid, and the first point is taste. So acids have generally sour taste. Sour means khatta. Acids, they are sour to taste. Like some of the organic acids that we could taste, like acetic acid, citric acid, malic acid, tartaric acid. So these are some of the acids which we could taste and tell that acids have sour taste. But it doesn't mean that we could taste all the acids. And we are not supposed to taste all the acid, because some of the mineral acids are very corrosive in nature. They are very strong, and they are not supposed to be tasted. Like for example, sulfuric acid, nitric acid, hydrochloric acid. These are strong mineral acid, whereas these are weak. They are organic acid, and we know that organic acids are weak in nature, and they are present naturally, like a citric acid in citrus fruit like lemon, oranges. They contain citric acid. Malic acid is found in apple, tartaric acid in tamarind, acetic acid in vinegar. So we have tasted all these things, and on the basis of that we could say that acids have sour taste. Second, physical state. Physical state. On the basis of this physical states, acids they could be solid or liquid at room temperature. In solid, we could see boric acid, citric acid, tartaric acid. So these are all solid acids. Why solid? Because they are solid at room temperature. Whereas liquid, we know the example of liquid like sulfuric acid, hydrochloric acid, nitric acid, phosphoric acid. So these are all acids that are liquid in room temperature. So phosphoric acid, I think it is solid. It comes in this category. And you could take another acid like acetic acid is liquid. So these are some of the example of solid and liquid acid. Now third point that we have to see is the effect of acids on indicators. Effect of acids on indicators. So what are indicators? They are complex substances. Complex substances. Indicators are complex substances that acquire different color in acidic and basic medium. So indicators are complex substances that acquire different color in acidic and basic medium. Now these indicators could be natural indicator or synthetic indicator. So we classified indicators under two headings. One is natural indicator and second is synthetic indicator. Natural, from the name itself, we could make a guessing that it could be obtained from nature, like example is litmus, and second is turmeric. So turmeric is also a natural indicator, and litmus, this litmus you could get in the form of litmus paper. In lab, it is generally used for testing a sample whether it is an acid or a base. So this litmus you will get in the form of two colored paper. One is red color litmus, another one is blue color litmus. Now we have to see the effect of acid and bases on these litmus. First we'll take litmus and then we'll take turmeric. So acid and base. So red colored litmus will remain red in acidic medium and it will changes to blue in basic medium. And blue color litmus paper will change to red in acidic medium and will remain blue in basic medium. So just to learn, you could make a trick like red is the color of danger, sign of danger. So litmus paper changes into red. In both red and blue will change to red color in acidic medium, whereas it will remain blue in basic medium. And turmeric, what would happen to turmeric? Turmeric, we know it is yellow color. Turmeric is yellow in color. It will remain yellow in acidic medium, whereas it will change into vermilion red in basic medium. So it will remain yellow in acidic medium. That means turmeric would not change its color in acidic medium, whereas it will become dark red in color. Vermilion means sinduri red. It will become sinduri red or dark red in color in basic medium. This we have seen this when suppose we are having this turmeric stain on our cloth, and when we wash it with soap, it will change. That yellow color of the turmeric stain changes into dark red color, because we know that soap that we use are alkaline in nature, and when this alkaline soap comes in contact with the yellow color of the turmeric, it immediately changes its color to dark red. So we can say that turmeric changes its color to dark red in presence of a base. Now we have to see synthetic indicators. Synthetic indicators, one is methyl orange, another one is phenolphthalein. And now we have to see the effect of these two in acid and base. So what will happen to methyl orange in acidic medium and in basic medium? This methyl orange is a synthetic indicator and it will change its color to pink or red in acidic medium, whereas it remains the same in basic medium. And phenolphthalein, it is a colorless liquid and it will remain colorless in acidic medium and it changes to pink in basic medium. One more type of natural indicator is there, that is called olfactory indicator. Olfactory. It changes its smell. And it changes its smell under acidic and basic medium. Onion is one of the example of olfactory indicator, and we know that onion has a very distinctive smell. And so what happens in case of this indicator, if we treat cloth dipped in onion, and if we treat that cloth with acid and base, so what happens? The smell of onion will remain the same in acidic medium. The smell of the onion will remain as such in acidic medium, whereas you would not be able to detect the smell of the onion in basic medium. No smell is detected in basic medium. So this onion also acts as an indicator. What type of indicator? As an olfactory indicator, means it depends upon the smell. Smell is not detected in basic medium, whereas onion smell remains the same in acidic medium. So these are some of the types of indicators. One is natural indicators. Under natural indicators, we have studied litmus and turmeric, and then synthetic indicator, methyl orange and phenolphthalein, and one more, olfactory indicators. Now we'll be seeing the chemical properties of acid. We'll change this to chemical properties. Now we have to see some important reactions of acid with different elements and compounds. Chemical properties. So I'm writing some examples of acid that we'll be using here in these reactions. These are the common acids: sulfuric, hydrochloric and nitric acid. So if I said chemical properties of acid, that means we'll be using these examples every time. So that's why I have written it. The first chemical property is the reaction of acid with active metals. And it will give the respective salt and hydrogen gases released. This arrow pointing towards upward direction, it shows that the resultant compound or whatever you are getting here as a product, that is a gas. So acid, when react with metal, say sodium, active metal means metals that are highly reactive. When we talk about metals, that means we are very clear that the elements that are present from group 1 to group 12, group 1 to group 10, 12, 1, 2, then 3, 4 up to 12, they are mostly metals, and from group 13 till group 17, they are mostly non-metals. So here what I said, the reaction of acids with active metals. So we will take some of the very reactive metal like sodium, potassium, calcium, magnesium, zinc, iron, aluminium. So these are the reactive metals. So we'll be taking any of the examples here to see the reaction. Hydrochloric acid plus sodium, it will give salt. Salt, we'll be dealing with salt separately in this chapter only. But for now, you just keep this in mind that salts are formed by replacing the hydrogen of this acid by a metal cation. And how you produce this salt? This hydrogen is replaced by this sodium, a metallic ion, and you are getting a salt over here, and this hydrogen is liberated. So for now, you just keep this in mind that a salt is formed by replacing the hydrogen of acid by any metallic ion. Take another example. You have to balance this also. Two sodium, two chlorine and 2 hydrogen. Take potassium, change the acid over here. You will get K2SO4, potassium sulfate plus hydrogen gas. Why this potassium sulfate is having this 2 over here? Because we know that the valency of potassium is 1 and sulfate is 2, and when we are writing the formula, you have to cross these valencies. So that is why K2SO4 is the formula for potassium sulfate. Take iron plus HCl, you will get ferric chloride FeCl3 plus H2. FeCl3 plus H2. Next, react this iron with H2SO4. We'll get FeSO4 plus H2. You have to balance these equations. H2SO4, potassium 1 potassium here, and here it is 2, so make it 2 over here. Sulfate is 1, hydrogen is 2. Now here, first we'll see metals, na? Iron 1, 1. Then we'll see non-metal chlorine 1, 1 over here. So what we would do here, we'll put 2. So it will become 3 2s is 6, make 6, and hydrogen 3. So it is balanced. Now here what is happening? H2, H2SO4, this is already balanced. So these are some of the important reactions of acids with active metals. Now second, we'll see the reaction of acids with metal oxide. Metal oxide. So we'll get salt plus water. So in the previous one, we got hydrogen gas here, but when we are taking metal oxide, it will change to water. So now we have to see what is metal oxide. Metal in combination with oxygen will give metal oxide. So take any of the metals, sodium, oxygen, potassium, oxygen, calcium, oxygen, magnesium, oxygen, zinc, oxygen. We have to satisfy the valency also, so we will be writing it later. First just write like this. Then what? Sodium, potassium, calcium, magnesium, zinc. Okay. Now we will satisfy the valency. 1, 2, 1, 2, 2, 2, 2, 2, 2, 2. So what formula it will have? Na2O, K2O, CaO, because this 2 will get cancelled out. MgO, ZnO. So these will be the formula of metal oxide. So now we will be taking these metal oxide one by one and we'll react it with acid. So product side, we know that one of the product will be the respective salt and water. So water is common in all. So just make water everywhere. Then I'll show you how to make salt. The most common example of salt is NaCl. So we'll make NaCl here. Na came from this metallic oxide and Cl from acid. The salts are having one positive and negative ion. We'll take H2SO4. So you could perform the reaction of this sodium oxide with HCl as well as H2SO4 also. So you could do it by yourself. No? I am showing only one reaction. K2O plus H2SO4 will give you K2SO4 as the salt and H2O as one of the product. CaO, HCl will become CaCl2 salt and water. H2SO4 will give you MgSO4 and H2O. HCl, if we take HCl here, we'll get MgCl2 ZnCl2. So you have to learn this equation. Means if acid reacts with metal oxide, will give you salt and water. So metal oxide, I told you how to make metal oxide. Then acid, take any of the acid. I have written 3 acids over here. You could make the reaction by taking any of the acid. Then make the salt and water. Salt will be common product in all the reactions which we see here in the chemical properties of acids. Now next is the reaction of acid with carbonates and bicarbonates. Now third reaction, reaction of acids with carbonates bicarbonates. So carbonates, it is a polyatomic group containing CO3 with 2 minus valency. Bicarbonates HCO3 with 1 minus valency. These are polyatomic group. So when these two react, you will see here the carbonate group is having C and O, carbon and oxygen. So definitely one of the product will be carbon dioxide gas. One of the product will be carbon dioxide gas. And water would be there and the respective salt. Now just take acid and take compound with carbonate and bicarbonate, like HCl is the acid. Take sodium carbonate and take sodium bicarbonate. On reacting these two, you are going to get NaCl as the salt plus water plus carbon dioxide gas. Here also the same, balance the equation as well. See, balancing is very important. Everywhere when you are writing the reaction, you have to keep on balancing the equation also. One more example, calcium carbonate and calcium bicarbonate. Reacted with HCl, we get calcium chloride as the salt, H2O and carbon dioxide gas. See, these reactions are very simple. You need not to memorize it. I am telling you the trick along with it. What trick? You just learn this. And if carbonate group is there, then carbon dioxide gas will be one of the product. There when we reacted acid with active metals, hydrogen gas was released. Then we have seen with metal oxide, water is released. So, because salt is common everywhere, only this you have to learn. What gas is released in all these reactions. So now here carbon dioxide gas is one of the product. Now we have to go for a test to confirm whether the evolved gas is carbon dioxide or not. See, I said we know by equation that yes, it is a carbon dioxide gas. But we would go for a test also. How we would confirm that yes, it is a carbon dioxide gas? For this, there is a very famous test called lime water test. Lime water is calcium hydroxide solution. This is calcium hydroxide. And when we pass this carbon dioxide through this lime water, we will get a white precipitate of calcium carbonate. We will get a white precipitate of calcium carbonate. So this formation of precipitate shows the presence of carbon dioxide gas along with water. So this is the test to confirm the presence of carbon dioxide gas. Similarly, there is a test to confirm the presence of hydrogen gas. In the first reaction, we have seen the evolution of hydrogen gas. There is a test. What test it is? Take a test tube, place a magnesium strip. What is this? A magnesium strip inside the test tube and add dilute hydrochloric acid to it. We know that when metal react with acid, we get hydrogen gas as one of the product along with the salt. And this is the test to confirm the presence of hydrogen gas. What you did, you took one test tube, put a small strip of magnesium and then pour dilute HCl. So after pouring dilute HCl, what you are going to get? You are going to get magnesium chloride salt plus hydrogen gas. When this hydrogen gas is released from here, you have to bring one burning candle near the mouth of the test tube. When you bring this burning candle near the mouth of the test tube, this candle will burn with a pop sound. This is a very distinctive sound of hydrogen gas. Not all the gas produce this sound. Only hydrogen gas produces this sound. That is why this test is used as a confirmation for hydrogen gas. So for hydrogen gas, we have seen this test, and for carbon dioxide, lime water test. So we have completed 3 reactions. First with metal, then metal oxide, then carbonates and bicarbonate. Fourth is the neutralization reaction, and it is very important. It has practical application also. Neutralization reaction. Neutralization reaction. What is the equation? Acid when reacted with base will produce salt and water only. In neutralization, when an acid is reacted with base, you are going to get only salt and water. No other thing is supposed to be present here along with these two products. If any other thing is also present, that means it is not a neutralization reaction. This reaction has practical importance, like when we are suffering from acidic stomach. Sometimes when our stomach is upset, we feel this acidity, burning sensation inside our stomach. That is due to the excessive release of hydrochloric acid. We know that hydrochloric acid is present inside our stomach, that aids in digestion. Sometimes if our digestion is not proper, this acid is released in excessive amount. And to neutralize the effect of that acid, we take a base in the form of tablets or liquid. Tablets or liquid. So when we take these tablet or liquid, a base, it will neutralize the effect of acid and we start feeling better. So this is the practical application of neutralization reaction. Take some examples. Again, HCl. See, very common reactions. Every time we are using these examples: hydrochloric acid, caustic soda, potassium, sodium hydroxide will give NaCl and water. You can change the acid here, change the base also. Like you take KOH, we'll get K2SO4 and water. Take one example of nitric acid also. NaOH, I am going to get sodium nitrate. Both are having 1 valency, so that is why its formula is NaNO3 plus water. So these are some of the example of neutralization reaction. Now the fourth reaction is with sulfates and bisulfates. The fourth reaction, sulfides and bisulfides. Sulfide polyatomic group this, and bisulfide HSO3 minus. So here you could see the presence of sulfur and oxygen. So definitely one of the product will be sulfur dioxide gas. Will give you salt, common, water and sulfur dioxide gas. Now the example is calcium sulfide and we'll take sodium bisulfide. When reacted with hydrochloric acid, you will be getting salt, calcium chloride plus water plus sulfur dioxide gas. Now this sulfur dioxide, presence of this sulfur dioxide is proved with the help of potassium dichromate solution. K2Cr2O7 is potassium dichromate. It is orange in color. So when this sulfur dioxide gas is passed through it, this orange color changes to green color. So this is a specific test for the presence of sulfur dioxide gas. The orange color of potassium dichromate gets converted into green color in presence of sulfur dioxide gas. One more reaction will take with sulfides. Sulfide S2 minus. So with sulfide we are going to get salt and H2S gas. Now what is this H2S gas? Hydrogen sulfide. Zinc sulfide, iron sulfide, lead sulfide, when reacted with acid, so you are going to get salt plus hydrogen sulfide gas. FeSO4 plus hydrogen sulfide gas. Here lead sulfate plus hydrogen sulfide gas. You can change the acid. Here you could take H2SO4 here, HCl, HCl, HNO3, anything. So the product will be salt and hydrogen sulfide gas, and this gas smells like rotten egg. And this is the very special feature of this hydrogen sulfide gas, that it smells like rotten egg. And if you are getting this rotten egg smell, that means you could immediately confirm the presence of hydrogen sulfide gas. So these are some of the important reactions of acids. Now in the next video we are going to start bases. Till then, have a nice day.